Hey guys, so in this video, we're going to be talking about the problem back to school 18 letter frequency. So essentially in this question, we're given a string S that can contain lowercase and space characters. And essentially what they want us to do is they want us to find what is the frequency of some specific letter in a given range. So in this example, they're asking us for the frequency of the letter H within the first 1 to 4 characters. So we're going to be looking in here, and they want us to they want us to answer back or print out what is the answer in this case. So how many H's appear in the first 1 to 4 letters? Well, the answer would just be 1. Then they're asking us between the letters 6 and 6th, or the 6th and 6th letter, what is the frequency of P? And if we look at the 6th letter, so 1, 2, 3, 4, 5, 6, so the range from 6 to 6 is just this character here, and the frequency of a P in that range is just 0. So we're going to print out 0. Then we're going to go from 15 to 26, and in that specific range, what we have is 2 letters of T. And that's probably something in here. And finally, they're asking us from 1 to 54, so probably the entire range, how many E's exist. So in this case, it would just be 8. So not only are we just given a range, we're given Q ranges, right? So, and Q, if we look at this, can be up to 10 to the 5. So one obvious solution that we might have if we don't use any specific algorithm or data structure is for every range, we might have to go through each of the characters and store a count variable or something. So let's say, for example, in 1 to 4, they want H. So we have 1, 4, and then we have H. In this case, what we're going to do is we're going to start at the first character, and we're going to loop through all the way until the 4th character. And by doing this, what we're going to do is we're just going to say at every step along the way for the variable I, for example, or the iterative variable, what we're going to do is say if, for example, S of I is equal to this letter here, so if it's equal to an H, so I'll use double equals here, then essentially what we want to do, and let me write that a little better. I'm not using my tablet right now, but essentially if S of I is equal to H, then what we're going to do is we're just going to increase some counter variable. And by doing that, what we're going to do in the end, after we've iterated through the entire range, is we're just going to print that count variable. Now, you might be saying, well, that's a pretty straightforward solution. Now, the problem with that solution is that it's pretty slow. So let's say, for example, at most, Q was 10 to the 5, right? So 10 to the 5. If Q is equal to 10 to the 5, and at every single query, we were to ask, what is the length of the string? Like that. Then, for example, if we wanted to ask, what is the frequency of E in the entire range? Well, the entire range, we're going to denote that as S. So the magnitude of S here. And what we're going to say is, if for each query, we're going to have to go through the entire range, then the overall time complexity is going to be O of, for each query, so for each query, we need to take the magnitude of S time. So in the end, this is pretty much our time complexity. And what can this be up to? Well, this can go up to, if we look here, 10 to the 5 and 10 to the 6. So if we multiply 10 to the 5 and 10 to the 6, then what we should notice is that this is 10 to the 11. Now, on many programming sites, on many online judges, typically 1 second is roughly 10 to the 9 operations. And it really depends on the online judge, but for example, on DMOJ, 1 second would be 10 to the 9 operations. Now, obviously, this is really slow. 10 to the 11 and 10 to the 9 is a magnitude of 100 times bigger, right? So what we're going to need is a really fast solution that can probably answer each of the queries in probably O of 1 time. So let's think about a solution that will do that for us. Okay. Now the solution here is that we're doing something like a range query, right? And what kind of data structures have we learned about range queries? Well, a very simple one would just be the prefix sum array, so PSA. And with PSA, what they want us to do is they want us to find what is the range of a sum, right? So, or the sum range, right? And the way we do that is we construct some cumulative sum array. And if we wanted a specific range, we basically take that entire range. For example, this was our range. We take the entire range, the rightmost range, and subtract the leftmost range minus 1. So we might subtract something like this. And this is a pretty good application of the prefix sum array. So think about it like this. For every letter that we have, we can kind of think about it as either adding a 1 or a 0 for that specific letter. So if we're just looking at the letter T, for example, and I'll erase this. If we're just looking at the letter T right now, we're just focusing on the letter T, then essentially what we should notice is that the frequency of the letter T, you can kind of think about it as a binary almost. If there's a T, then you add 1. If there's a letter other than a T, then you add 0 to your range, right? So for example, this is what the prefix sum array would look like with the letter T. So it would look like 1. Then because there's no more 1s here, right? There's not a 1, so we don't have to add a 1. Then we basically have a 0 here, right? You can kind of think about it once again as binary 0 or 1, and then we're going to construct the prefix sum array out of this. So there's going to be a bunch of zeros here until we see another T. So there's going to be another 1 here. Then we have a bunch of zeros, a 1, a bunch of zeros, another 1, a bunch of zeros, and it'll just keep going on with a bunch of zeros. Now, if we were to construct the prefix sum array out of the letter or the frequency of T, then we would have 1, a bunch of zeros, then we have a 2, a bunch of zeros, a 3, and actually, sorry, this wouldn't be a bunch of zeros. It would just be a bunch of 1s. So I'll reconstruct that. It'll be a bunch of 1s, so I'll like denote that as this. And then when we see another 1, we see a 2. Then a bunch of 2s, then a 3, then a bunch of 3s, and then a 4, and then a bunch of 4s. Like that. So this is what the prefix sum array is going to look like for just the letter T. And if you wanted the sum of the, or if you wanted to know how many T's exist within a certain range, so for example, if we wanted from here to here, right? So we know that in this specific range, there's going to be 1 T, right? So from this character to this character, we know that there's going to be exactly 1 T. So how do we do that? Well, we take the frequency, we basically use the prefix sum array idea. We take all of this and subtract the left range minus 1. So subtract all of this. And so this works actually because you can kind of think about it for each and every single character. So let's code this up. And we pretty much do that once again for each character and each index. Okay, so let's try coding this up. And the way we're going to code it up is simply by just doing a regular prefix sum array, but for this time, we're going to be doing it for each of the 26 letters that are possible. So first what we're going to do is we're just going to take in the string s. And I've already created the buffered reader class here, so make sure you remember how to do that. And let me just remove this, sorry. Okay. I'll include this throws exception here. Then what we're going to do is we're just going to create the prefix sum array, but for every single letter. So we're going to create a 2D prefix sum array here. The PSA is equal to new int. And how many letters do we have? Well, we have 26 letters, right? Or that's the size of my array, right? And then what we want to do is we want to do this. We want to create a prefix summary for each letter for the entire string. So what's the size of the string? The size of the string is just s.length plus 1. And remember that we want to do one indexed for these kind of problems. So what we're going to do is we're just going to loop through the entire string like so. And what we're going to just do is we're just going to go through each of the 26 characters, right? And what we're just going to say is PSA j of I is equal to PSA j of I minus 1, right? So what that tells me is that for every letter, we're just going to increase that character, or we're just going to take the previous value, right? And then what we're going to do is we're just going to actually update the current PSA value. So char c is equal to s.char at j minus 1. So that's the, I minus 1. So that's the ith character. And if c is not equal to a space, right, then what we're going to do is we're just going to say PSA of c minus a, right, to get the index, right, to get the number value. And we're just going to say of I plus plus, right? So right here, all we're doing is we're just taking the previous value for every single letter, right? Because even though there's no t there, right, even though there's no t here, it would still be a 1. And that same idea applies for every single other letter. But if there happens to be a t there, all we need to do at the current index of the string, all we need to do is say increase the frequency of that letter at that index, right? So the next thing we need to do is we just take in the letter q, which is the number of queries that we have. So the number of queries, we're just going to loop through this one by one. And for the query, we basically have 3 parts of it: the left range, the right range, and then the letter that I want to be looking for of the frequency, right? The frequency of that letter in that range. So that's just read. And to get just the character, .char at 0. The final thing we need to do is just print out the answer. So we basically go to PSA c minus a, which is the same thing as just indexing it by 0, right? We're shifting it all the way back to a. We go from b, right, the right range, minus PSA of c minus a once again, but this time to l minus 1, right? Just the regular prefix summary stuff. So let's run this program here. I'm going to take in the sample input, and I should be expecting 1028 for my answer. 1028, perfect. So let's submit this to see if it works. And I'll be using Java 8 for this. And as you can see, it works perfectly fine. So this is pretty much the code for Back to School 18 letter frequency. So this is a pretty good application of the prefix sum array algorithm. And you'll kind of see this not too often, just this kind of specific application. But there's a few problems on DMOJ that use this kind of idea where you're taking the frequency of the letter within a range, right? And you use it as your prefix sum array. If it's the letter you're looking for, you add a 1. And if it's not, you basically add a 0. Construct the prefix sum array, and you can get the frequency of that letter within a range. And that's pretty much it for this video.